Hey guys, welcome back to my series on restoring classic late 40s American black and white electrostatic televisions. In this series I'm going to be pointing out some of the differences between these sets and the more common magnetically deflected sets, give you some tips, some tricks, some suggestions, some pitfalls to avoid to get these up and running. Now, if you've got a similar set and you've chucked it out in a similar manner and you've gotten similar results, you're in fantastic shape, as are we. What do I mean by that? I mean, it's all here. It hasn't been torn apart by somebody trying to fix it or made modifications to it. It's not covered in mouse urine. All the tubes test good. The picture tube seems to be fine. So, I don't see any hesitation, any reason not to just go full bore into this. Order up high voltage caps, any parts you might need, and let's start working on it. But we shouldn't get too hasty. There are some basic things we haven't checked. If you've worked on radios or other TVs before, you might be thinking, hey, you haven't checked some really fundamental stuff, and you're right. What does anything need that runs on electricity and need to work? It needs a power supply, and the heart of that is a power transformer. I haven't checked that out. Haven't ohmed out the filter choke, the audio output transformer, IF coils and all that. Why? Well, I've worked on a lot of sets, and it's rare to find one that has a bad power transformer that hasn't been been underwater, or there's just, some really visible signs of deterioration, or somebody had plugged it in and if the capacitor had vented and the rectifier tube had melted, it probably damaged the power transformer. Well, we don't see any of that, so I'm pretty darn confident that this is fine. Filter choke, we did see a glob of wax. That's a little more concerning. And the other stuff. Now, one reason I'm not all that concerned about it, aside from I think it looks, it's probably fine, is that these are relatively common. I even have a couple parts chassis. They say the power transformer was bad, I can get one. Heck, you can probably even get one that was made new. It'd be a little expensive, but there's nothing particularly exotic about that, or the filter choke, or the audio output transformer. That's all obtainable stuff. The most difficult thing is going to be your picture tube and that high voltage coil inside. Even with that, because they were using the Motorola sets, and they're out there. They're out there. The controls are straightforward, like that volume power switch that's been replaced. You can get all that stuff. Alright, so where are we going to go from here? Well, I want to talk very briefly about equipment you might need to work on a set like this. For the most part, it's no different from the same stuff you'd need to work on a radio. You're going to need a good meter. Be it VTVM or a DMM, digital multimeter. A Simpson type VOM, I'm not as crazy about those because they're not high impedance like this is. And these are so inexpensive. There's just get one. Is what I'm saying. And the newer, fancier ones, they can measure capacitance and measure transistors and do all kinds of things. I, like many other YouTubers that work on vintage stuff, have a Fluke 27 FM. In fact, I have several of them. They're from the early 90s, maybe late 80s into the early 90s. Made for the military, I do believe. There were gobs of them on the surplus market in the past. They're still out there. It seems like price has gone up, probably at least in some small part by a lot of YouTubers using them and increasing demand. But they're still out there. And one of the really neat things about these is if you get the kit, they come in a plastic carrying case with the probes, and they come with, hang on, they come with this if you get the full assortment. This is a high voltage probe, but it's only good for 6,000 volts, which is perfect for all these electrostatic sets. Plugs right in here where your positive and negative leads commonly go, and you've got a little ground clip. In this case, because it's a cold chassis, we can just clip that to the chassis. We can probe on our high voltage circuit and read it right on the meter. Do you have to have a high voltage probe to work on one of these? No. You can just figure, it'll probably be fine. Do you do your basic work, replace any tubes that are bad, replace caps that are bad, power it up, and ideally the picture tube lights up. And once the picture tube's lit up, that's your other piece of test equipment. It's essentially a built-in oscilloscope. Once you've got something on the screen, that helps you troubleshoot things. If the image is wavering and twisting badly, you probably have 60 hertz or 30 hertz ripple in your power supply. If the image is distorted horizontally, you have problems with your horizontal circuit. If it's distorted vertically, you got problems with your vertical circuit. If there's no video, no image, you have a problem with your video circuitry. So that's built-in test equipment. This will get you very far. So we can measure resistance with this, we can measure voltage with this, we can measure current with this. Another handy thing to have is an isolation transformer, and really handy to have one that's built in Variac. Otherwise, it's nice to have them separate. But really an isolation transformer. Not on this, because it's a cold chassis, but most electrostatic sets do not have power transformers, and they're hot chassis. You really need an isolation transformer. What does that do? Well, it's a power transformer with a 1-to-1 ratio. You put 120 volts in, you get 120 volts out, but it's electrically isolated, meaning if you take an oscilloscope that is grounded and you clip it to this, you're not going to have any problems. If it's a hot chassis and you've got it plugged right into an outlet, and depending on which way you orient the plug, you could very well have this connected to the hot side of the AC line, and if you clip your grounded scope lead onto it, you're essentially shorting things out. You're going to blow a circuit breaker or blow a fuse. Variac is not essential. It can be nice if you want to try reforming the caps. I don't think it's essential, especially if you got a dim bulb, which is a current limiting device. That will save you if there's a short somewhere. The bulb will absorb the power rather than your set. In my case, I have a Syncor PR57, which is a combination isolation transformer and a Variac, and it's got a fuse, and it's got a circuit breaker, and it's got a current meter or voltmeter, depending on what mode you're in. So it accomplishes a lot of things. Yeah, they're a bit expensive. They're a little hard to come by. They're not made anymore, but there are similar devices out there. You don't have to have one. I'm just saying you get by with an isolation transformer and a dim bulb, or in this case, just a dim bulb, but it's a nice thing to have if you can get one. Now, if you get the bug and you really want to get into TVs, you might want to just get a full-size high-voltage probe. This is good to, I think, 40,000 volts, so you can work on newer sets, color sets that have upwards of 30,000 volts on them with one of these. But for electrostatic sets, you can see how much smaller it is. I kind of like using these. Otherwise, soldering iron, needle nose pliers, side cutters. I use these all day, every day in the workshop. And these accomplish so much of what I need to do. 1/4-inch nut driver. And it's the reason why these tools are right here on my workbench, right in front of me, is because I use these all day. Pocket knife can be handy. This is basically it for my hand tools. Almost every screw on here, except for the chassis bolts, every screw on here is going to be a 1/4-inch. And these are great for clipping leads. These are great for manipulating leads, and pocket knife just when you pry that base off the CRT. Meter and a good soldering iron. Ideally, a nice temperature controlled one, but again, not essential. If you're going to work on a lot of stuff, I recommend just invest some money, get a Hacko, get a Weller, so you can dial in the temperature. The temperature control irons are nice because when you say I want 650 degrees, it's going to adjust the current to the tip to keep it at 650 as you're working on joints. Some of these joints can be pretty big, and if you don't, just say like a 35-watt pencil iron, you put on a big joint, it's going to cool off the tip, and you're going to have a really hard time melting it. With these, it'll pump more and more current into it to try to maintain the tip temperature, and you'll have a much easier time melting large joints. Hey, wait a minute, what about all this stuff? Well, sure, it's nice to have, but we should be able to get the set working without an oscilloscope. without a sweep marker generator, without a spectrum analyzer, without even a pattern generator. It can all be very useful and very handy, especially if you run into something really unusual or somebody has really messed up the alignment on the set. I don't think we're going to need it to get a decent image. If you want the absolute best possible image, yeah, you might want to do an alignment. And pattern generators and signal injectors and all that, also handy if you want to do some heavy duty troubleshooting, but we'll probably get by without it. Now, yes, of course, we will need to feed some sort of signal into the set since there are no more over-the-air analog broadcasts. We do need a signal source of some sort, but we don't necessarily need a full-blown, fancy, universal video generator. We could use something like an over-the-air converter box or a little pocket vintage B&K pattern generator that runs off a 9-volt battery. There are a lot of inexpensive little pattern generators out there, or an old VCR, or a DVD player. Anything that's got NTSC RF out, or composite out and hook up an RF modulator, you can feed into this set, or any other vintage set right to the antenna terminals. But that's getting way ahead of ourselves. We got a lot of work to do, but by the time we're at the point where we've got a nice stable bright raster on it and some hiss out of the speaker, then we can worry about feeding a signal into it. There is one other thing we need. Not only very useful, you might go as far as to say indispensable. That's some service info, at least a schematic. Yeah, we can look at this, and if we're lucky, can read the parts values off of everything and just replace that with what we, replace what we see with a new part. But it'd be nice to have a little bit of a guide. So this is a 17T1 chassis. How do I know that? Since the label has gone off the cabinet, well, it's printed on the back of the chassis. It's a little worn out, but I knew what this was when I saw it, so I know that it's worn out, but that's a 17T1. It also says R18 here, and I mentioned earlier that there's an R stamped on the picture tube in the transformer. It's revision R. I'm not sure what the 18 means, but it's 17T1. That's the important thing. Now, if you go to Sam's Photo Fact and go to their index, or go to the Rider's Index, I don't think there's a 17T1 listed. But luckily, I have this, a Wallace Telaide for Admiral that covers the years 47 to 51. This has got a schematic for everything, including the 17T1, which is right here. Now, it's probably 99% the same as a 19A1, for which there's a wealth of service info out there. But since we've got it, we'll work off of this. It's nice, big, clear, easy to read because this, like I said, is a fairly basic set. So let's take a quick review here. Power comes in, power switch, power transformer. So all it's got, 6.3 for all the tubes, except the rectifier. We got a 5-volt winding just for the 5Y3, and we got secondary. That's it. And just the single voltage here. Out of that 5Y3 goes through a rectifier, a filter choke, and that powers the whole set. Just one major voltage rail there. Our high voltage down here. That's 6V6 feeding this thing in the dash line here. That's the shielded box, and that's that high voltage generating coil, high voltage rectifier. So the line out here is our high voltage. It's all the way over here. Here's all those bleeder resistors I talked about. These are the high voltage coupling caps. There. These are all of our 6SN7s, 6SL7s. These are all of our oscillators and output tubes. Get up here is our tuner with a 6AG5 RF amp, 6J6 oscillator mixer. Here's our 3-stage IF, 6AU6, 6AU6, 6AU6. 6AL5 video detector and AGC, 6AU6 video amp, and finally up here 6AU6 audio IF, 6AL5 ratio detector, 6SQ7 audio amp, and then our 6Y6 audio output, and that is it. That's all there is to it. We just need to make it work. Now that's an Admiral. Let's take a little look-see at another very popular, very common set, and that is a Motorola. This is a TS18 chassis. The earlier TS4 is very, very similar. And the circuit is very similar, except this is series strung. So we've got some strange tubes in this. Oh, not strange, but they're not all 6 tubes. We've got, for example, let's look at the audio. 6AU6, hey, same as the other one, 6AL5 ratio detector, but then a 12SN7, then a 25L6. They wire these tube filaments in series, and they want it to add up ideally to the line voltage, so you get much higher voltage tubes in some places. Let's jump down to the IF, 6AU6, 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 3 stages, exactly the same as the Admiral. 6AU6 video amp, same as the Admiral. One innovation in this, it's the first application I know of in a commercial. It's a 1N34 diode way back in '47, right after they were invented, basically. That's for the detector. It saved them 1 tube. And down here, same type of sweep circuits. 6SL7 is very similar circuit to the Admiral, but 12 SN7s instead of 6 SN7s. And there's our 7JP4. We got all of our high-valued resistors in a bleeder network. We've got our coupling caps. High voltage oscillator, but in this case a 25L6 instead of a 6V6. The main thing that's goofy about this is, well, not goofy, but strikingly different from the Admiral, is the power supply. So no power transformer. Instead, we have a 37 ohm resistor going into an electrolytic capacitor, and then these 2 goofy looking things, those are selenium rectifiers. And they're configured as a voltage doubler. And then we got more caps over here, and then a B++ and a B+. So this runs on a high voltage and a medium voltage, or higher voltage, and then there's of course a high voltage. So it's a high voltage supply, a B++ supply, and a B+ supply, and it's a hot chassis. So a little bit different here. No 5Y3, it's a solid state power supply. And the tube filament strings are down here. It's a little confusing to see because there's a bunch of caps they put in there and filter chokes to keep noise off the filament. They're all wired up in series. They don't add up to the line voltage, so we've got 2 hefty dropping resistors here. And a resistor there and a resistor there. All those resistors get really hot, so they put them in a special thing called a ballast tube, and here's one of them. And these are almost always bad, and even if it isn't, you should replace it anyway. So rebuilding these is one of the key things to getting a Motorola set working. I have a dedicated series just on designing a replacement for this and building it. Watch that series if you want to know more about this. But otherwise, they're very similar designs. Okay, let's try to fire this puppy up. All the tube designators are stamped right in the chassis. It's filthy, so I can't read them all, but I know where some of these tubes go back. There's where our output tube goes. So I'm just going to pop a few of these back in so we can power it up with the rectifier tube out. And I want to see, do the tubes glow? Is the power transformer any good? Some of these are hard to read. Oh. Trying to figure out what these are. There's 2 of these are 6 SN7s and one is a 6 SL7. I don't want to mix them up. Well, here's the 6 SL7. Get in there. Just try to double check. Oh, that's 5Y3. Yeah, that would have been really bad. So these got to be the 2 6 SN7s. Alright, that's enough. Alright, let's take power and AC interlock. Now, if you're missing the power cord, this is what the original would have looked like. Non-polarized, has ears that would have attached to the back of the set. You're going to need them. Unfortunately, well, they haven't made them in a long time, and collectors have gobbled them up to replace or repair sets over the years, so they're a little hard to come by. But you can make do if you get... power cord looks very similar for other things like coffee pot or other electronic devices. You might have to split it because the pins might not line up perfectly. But go to your hardware store and look in like the appliance section or where they have the electrical section and see if there's any replacement cords. And you should be able to find something that fits. Alright, let's give this a try. I'm going to leave this off, turn this on first and make sure I've got output voltage. It's around 117. Turn it down a little bit. Yep, we're good. Turn that off. Do this. And now, typically, I leave the set turned on while I'm working on it and use the power switch on my variac or isolation transformer. Save some wear and tear on the power switch on the set. Nothing else. And this one doesn't feel good. I probably will end up replacing this. It just doesn't give me a lot of confidence when I turn that. Now I'm going to switch this to current mode so I can see how much current draw it is when I turn it on. And here we go. None. Yeah, I knew I didn't like that power switch. I think it's bad. These don't have fuses. Oh, I can also try wiggling this. Maybe it's not making good contact. Alright, hey, we got our first problem. Let's take a look back underneath the chassis and make sure that that control is wired up properly, and then we can check the resistance across the leads on the switch too. Power switch is up here. It does appear to be wired up okay. Let's turn it on, and I have my meter in continuity mode. Let's check it. It's no good. Leads on there and exercise it a bit. Thought I might be replacing that. So let's bypass it. Just going to use some alligator clips. These are not exactly rated for 120 volts AC, but be okay for a little quick test here. So I'm just going to clip this right across the power switch. It's unplugged right now, by the way, and the variac's turned off. So, no shock potential there. All right. Now let's hook this back up and try turning it on again. No, I definitely have to rely on the switch on my variac. Okay. And here we go. That's better. A little bit of a surge because the tube filaments are cold, they draw more current and it settled right down. Yeah, it's just going to stay stable. Alright, cool. So, for now, I'm going to take a piece of wire and just short that power switch out. Because this is not safe to have hanging like that at all. And then I'll be able to flip this down and we can see the tubes lighting up on the top side. And I'm just going to go ahead, do a little bit more chassis cleaning and put all the tubes back in except for the rectifier tube. Chassis is cleaning up beautifully. However, I'm not using CLR. I actually went through a number of cleaning products, and in the end I found that denatured alcohol is working the best, and occasionally some acetone or brake clean. Chassis is cleaning up beautifully. However, I am not using CLR I'm not using Windex, not using simple green. I'm actually using denatured alcohol or acetone in some really stubborn areas, because it turns out that it has almost like a waxy coating on it. Now, this came from Texas, and I'm wondering, was it in an area where there was an oil refinery or something like that, and that accounts for the stuff that got deposited on here. You can actually scrape it off too, but denatured alcohol works quite well. So that gets me to this point. I was replacing all the missing screws on this high voltage box, and I got to thinking that I really do want to clean this up better, so I'm going to take it off. Plus, it gives me a chance to give you some tips on how to take it off. On these particular sets, it's actually similar to how they do their magnetically deflected sets. So Admiral, I mean, they put a canvas strap across the front with a chassis cleaning up remarkably well. However, I am not using CLR. It was working okay, but some areas it wasn't really doing much, and I noticed that it had kind of a waxy substance on the chassis. I ended up using not simple green, not Windex, but actually denatured alcohol, and in some really stubborn areas, acetone. And I actually wonder, not only did this set came from Texas, maybe it was near a refinery, and some type of waxy, oily residue got deposited on the set. I don't know. You can kind of scrape it off with your fingernail too. Well, anyways, I've been cleaning around the chassis and got me to this point, replaced the missing screws on the high voltage box, and I decided I really want to clean this up, the shield especially. So I'm going to take the picture tube out. Plus it gives me a chance to show you how to do it safely, carefully. Now, the main thing holding this down on the front is this. It's actually a canvas strap, and Admiral uses on their magnetically deflected sets from this era too. There's a hold down on either side, a metal strap with a screw on either side with the canvas strap running down the middle. To get it off, well, we just need to loosen up that strap. So again, 1/4 inch nut driver, loosen up these screws, and pull the strap out. You see there's a blob there. They put like tar on there to kind of hold it down in the middle. So that's the front. And now it's quite loose. Now it's also held on in the back a little bit. Not that securely, but this. So you're going to want to squeeze these in and carefully move the whole thing forward. So these are engaging with, actually slide this back rather, and take this off. I'll show you what that's hooking onto as soon as we get this out of the way. Now we can take this, we're going to have to take this out of the tar blob, and the whole thing should just lift out right now. And there we go. Just that easy. Rubber cushions down here. These are in fine shape. We'll keep using them. If they were rock hard, you might want to replace them. Here's a look at that shield. It goes all around. And there's some cardboard under here. So you don't have the metal directly against the glass. I don't recommend messing with that. If you want to get the shield off, you have to slide it this way over the base, and this cardboard's going to get in your way. It's not easy to get this off. So if you don't have a really good reason to, don't even try. And this is an RCA, by the way. I find it interesting that there are RCA branded 7JP4s, but RCA never used a 7JP4 in anything to my knowledge, certainly not any production televisions. So what was that spring hook going on to? This. There's a little mounting bracket here. Again, 1/4 inch screws. You got a wire running through it. So when it's in position, you're sliding this down, so when you want to reassemble it, again, go through the base, and it's going to go onto that. This wire, that's your video signal. You want to keep it separate from the other signals, the other wires rather, to minimize any chance of crosstalk of pickup from this into the CRT base. What that also means is if you want to clean in here, you can't just take these 2 screws out and take the bracket out, because you got a wire running through that hole. You have to disconnect the wire down below. I don't know if I'll go that far, but now I can clean this up. I'll give you a little taste of how the alcohol works on that. So you saw the CLR before. Yes, it does work, but this works better. The same idea. I'm just brushing it on directly right out of the can. You see, it's dissolving it. It's weird. Or maybe this was like in a mechanic's garage or something like that, or steel mill. Like, I don't know what environment this set was in or it picked this all. I don't think this is from cigarettes. There's no odor whatsoever with this set either. Maybe just a faint mustiness underneath. And then just take a bit of paper towel. And there we go. And just need to do a little bit around. There's a couple screw heads coming up from below. So I got a little bit more to do with this, and then we're going to go underneath. And I'm going to start work in this high voltage area. So I want to power this up sooner than later. Before I do that, I want to do 2 things. I want to replace the electrolytic cap, filter cap over here, and replace those resistors with the VR37 high voltage rated resistors, and replace the 5 high voltage caps. Then we're going to try powering the setup. No, there is another reason to remove that picture tube beyond cleaning, is that once it is out, you have a lot more freedom with positioning the chassis while you work on it. So with that out, I can put this completely flat. Instead of put a little support underneath this transformer, and I have a little support up front. It's super stable, rock solid to work on. But still, I gotta recommend, if you're not comfortable with removing it, don't. And work with the set on its side rather than completely upside down. It's completely possible. That's how I've done them in most of them in the past. But I do have to admit, with it out of the way and with this completely upside down, it's even easier to work on. So we're going to go after these 5 caps right now, and then these resistors. I think I am going to go with the white ASC rather than these guys, but either one, again, will work just fine. Here's a little progress update. I replaced all those bleeder resistors with their high voltage equivalent, and I clipped out the old high voltage caps. Now that I can see them better, 2 are new. The other 3 are original. How do I know they're original? Because they have Admiral part numbers on them. That 8A47, and a little hard to read on these because they're so coated in wax, but I can see like it's like a 64A or something like that. These 2 that say Chicago television capacitor, those are the replacements. Alright, so I'm going to be diving in and replacing those with some of these guys. Now I think is a great time to break out the whiteboard. When I gave you a chassis tour, I really oversimplified this high voltage stuff. What I want to talk about, try to explain to you guys, is why do we need these 5 high voltage capacitors? Why do we need these bleeder resistors?